its compounds. Yesterday we started with the hydrocarbons, right? So what is hydrocarbons? What is hydrocarbon?
Compounds are majorly completely made of only hydrogen.
So compounds which contains only hydrogen and carbon, we call it as hydrocarbons. You don't know it. Karthik, tell me what are the different types of hydrocarbons? Unsaturated. What are saturated hydrocarbons? Yesterday so much we studied this.
In which all carbon atoms are there.
Everywhere it is.
Just only one single bond. Oh, single covalent.
So correct. Saturated hydrocarbons means they contain only single bond. What about unsaturated hydrocarbons? If they are having at least one double bond or one triple bond, then they are called as unsaturated hydrocarbons. In unsaturated, so which is stable in nature? Saturated, correct. Saturated hydrocarbons are stable in nature. Okay. They are stable in nature. So saturated hydrocarbons are the unstable in nature. Okay. So alkenes, we studied about the alkenes. What is the general formula for alkenes? Yesterday I think we wrote alkenes. See, alkenes and alkenes, what is the difference? Here it is E here, earlier it was A. A means single bond. Okay, E here, this will indicate the double bond. Okay, that is the thing. And general formula for alkenes it is what? CnH2n. Okay, for that it was +2 is there, that is not there. Okay. First one is not possible. Write the second one, it is ethene. What is the molecular formula? C2H4. And what will be its structural formula? 2 carbon atoms, write like this and fill other 2. 2 is already there, 4 bonds should be there. So it is with hydrogen. Okay, this is the first one. And write the electron dot structure for this. You did? Everything done? Okay. Next, after ethene, it is right? Propene. Instead of propane, it is propene. Eth we wrote, no? Meat is not there because you can't have one. Y and E, it is for triple bond.
Oh.
Y and E for triple bond, E and E for double bond.
And this is correct.
I can't see from there. Wrong. Which Y and E it is correct. We are writing about E and E. This is
The
propene. Wrong. Only one double bond is there. You've written. C3H6. Okay. Propene. So general formula, carbon atoms, prop means carbon atoms will be 3. So it is C3H6. Okay. So you will have 3 carbon atoms. Listen once this. Listen here. 3 carbon atoms will be there. There is double bond. What we are writing here, it is having one double bond. Okay. So if I write double bond here, two double bonds here. For this carbon, remaining will be two other double bonds. For this carbon, you have already three, so you have only one. Here it is one, so write the remaining. You will get it is filled with the hydrogen. See, again I repeat, you have three carbon atoms. Okay, you have one double bond. I'm writing here. So two is two double bond, two bonds here, third, fourth. For this, 2, 3, 4. For this, it is 4. So if you count how many carbon is there? 3. Hydrogen 2, 3, 4, 5, 6. Understood, no? Understood or not? Here, you can, it can be there. You can have that also. You can have like this. Okay, then you have 3 here. This is also propene only. 1, 2, 3, 4. 1, 2 is over, just 2. Again, it is C3H6 only. Both exist. Okay, both the compounds will exist. Write that. You should write it. Like this, we'll write in the next screen. Once I'll write one, next one you can write down this. Understood? No, you can have the double bond either in the first one or the last, and for that also little bit name we can change. That is 1 propene, 2 propene they call. 1 propene means for the first, if you number from here, for the first carbon you have double bond. For the second carbon you have the double bond here. So we call it as 1 propene, 2 propene they call. It is there. Propene, right, 1 second, PROP. Here it is C3H6. It will be there. So structure, it's see, while writing electron dot structure, it's better you write once the structural formula, from that you write the electron dot structure. 2 here, 3, only 2 remaining. We'll write like this. That I'll write. This is structural formula. 3, 4. For this, we'll write the electron dot structure. For the first carbon, you have 2 electrons. See here, 2. How many bonds is there? You have to count. See here, 1, 2, 3, 4. For this carbon, you have 4 bonds. For this carbon, 1, 2, 3, 4. For this carbon, you have 4. Understood, no? So, see here, for this carbon, 2 here, and another one, I'll write 1 cross, H with 1 dot. Here also, H. Here 1 bond means 1 cross 1 dot. Okay. For this carbon, you have 2 cross, 1 cross here with 1 dot, and here 1. Okay. For this carbon, here is also cross, H 1 dot, H 1 dot, H 1 dot. Okay. Hydrogen grouping. These 2 are the hydrogen. Okay. For this carbon, 4 here, 5, 6, 7, 8. For this carbon, 2, 4. Okay. 2, 4. 6 is done. This 2, 8. For this carbon, 2, 4, 6, 8. Okay. And here, if you observe, each one is sharing 2, like carbon to carbon, 2 pairs are shared. That's why 2 bonds. For carbon, I have written cross as an electron. for hydrogen dot. Okay, clear? Next one you will only write. Third one, after third one, fourth one is butene. What is the structural formula? Molecular formula? C4H8. So we did butene, then it comes a pentene, C5H10, 1 minute. Then comes the last one, hexene, C6H12. I think everyone did, right? Anyone having doubt? Gavin, see here once if you have doubt how to write. See, 6 carbon atoms, no? 3, 4, 5, 6. I'm writing for hexene. 6 carbon atoms. I will write double bond. Anywhere you can write, think I'm writing here. Okay, rest all are single bond. You can write any place. Okay. For this carbon one, only one bond is there. Remaining 3. I will fill with the hydrogen. Here already 3 is there, 1 hydrogen. Already 3 is there, 1 hydrogen. Here 2, so 2 hydrogen. Here 2, so 2 hydrogen. Here 1, so 3 hydrogen.
Will you draw the structure?
For electron dot structure for this? Okay, next page I have to draw. No space.
Wait one.
Understood, no?
I don't get it. Wait, what?
Correct. For this one, no? Okay, I'll write fast. Wait. This one. Okay, I'll write electron dot structure. For this carbon, who have doubt, just see once. Next we'll go further. Okay, last one I'm writing this. Carbon we have 4. No, hydrogen 1 dot. For this hydrogen, Gavin, see here how to write. For this carbon, here hydrogen 1 dot. For this carbon, we have the single bond here. So 1. 2. You can take anywhere. So just to know everything. Two, three, 4. Okay, let's just try.
Bro, I was writing the Excels.
Yeah.
2 seconds. Look at this. Time for next. Nothing should go there.
Two grouping for hydrogen. 8 grouping for carbon. 2, 4, 6, 8. Here 2, 4, 6. One extra I have written here. This is not there. If I write, I have to write again. I don't know. Okay. That portion is not there. Again, I have to erase this complete thing. I have to write. That's why I'm doing that. Okay.
490.
It's like minus.
This will be the thing. Okay. We'll go for alkynes. We'll not get started. Okay, shall I clear this?
That's okay.
Why?
1 second.
Okay.
Bro, only towards the
Okay. Next one. Alkynes. In this only hydrocarbons don't talk. We'll study about alkynes. Okay. So write down this. Carbon. Alkynes are hydrocarbons. Write down this fast. Hydrocarbons which contains at least one triple bond. At least one triple bond. Okay. We studied alkanes. Shh. Listen here. We studied alkanes, alkenes, next alkynes. Y will come there. Instead of A or E, it is Y. Okay. Alkynes are hydrocarbons which contains at least one triple bond. Alkynes are hydrocarbons which contains at least one triple bond. So in this general formula, what is the general formula? We have CnH2n minus 2. Okay, first, this is unsaturated only. Yeah, it is an unsaturated hydrocarbon. It is unstable in nature. Single bond only it is more stable when compared to that. Okay. It is unsaturated hydrocarbon. CnH2n minus 2. It is an unsaturated hydrocarbon. So only 2 we will write for this. Anyway, you know everything else. Meet here also it will not come because one carbon it will not make triple bond. So it starts with ethine. Ethine. Ethine will be what? C2. C2. C. 2 carbons, triple bond. 1 H here, 1 H here. 3 bonds plus 4. 3 plus 1, 4. That's all.
I do it for propane.
Okay. Then for propane. C3, 6 minus 2, 4. Anyway, you know, no? 3, you should say. It will be like this.
What 20 carbons you have? 20 elements.
No, don't write that now. This much is understood, no? Triple bond means 3 pair of electrons it is sharing between the same 2 carbon atoms. Triple bond means 3 pair of electrons sharing between the 2 carbon atoms. Right? Propane. Okay. So 3 here, 3 2s are 6, 6 minus 2, 4. So you will get 3 carbon atoms. Here, if I write triple bond, there is only one hydrogen. Here, no hydrogen because all the four it is filled here. So, remaining three here. That's all. Rest you know, no? No need to write.
We need to write that.
No, no, no. Not required. We'll do this on the next week.
I do that.
Just write this much enough. We'll go for next allotropes of carbon and their properties, and it's few other things.
Always. From 0 to 0.
Nitra, turn this side. Okay. We'll next topic. Allotropes of carbon and their properties. Okay. What do you mean by allotropes of carbon? See, allotropes property means elements exist in their different form. Okay, so that means they have different physical properties, but they have same chemical properties. That is, we can take like we have diamond, graphite. Okay, diamond, graphite. Then we have coal. Different types we have. Then we have it's a new one actually what they have discovered, Buckminster fullerenes. Write down this. Buckminster. Yeah, it is the scientist name Buckminster fullerenes. Okay, so these are the examples of allotropes of carbon. Okay. Diamond, graphite, coal, Buckminster fullerenes, all these are allotropes of carbon.
So probably.
Allotropy, write this. Allotropy is the property by virtue of which an element exists in more than one form, and each form has different physical properties, but identical chemical properties. Okay, Tamim, tell me why it has identical chemical properties. Just now we told why it is having identical chemical properties. Keisha? They contain the same thing. All contains the carbon itself. So their chemical properties should be same. Write down. Carbon exists in different allotrophic forms. See here again I repeat, allotropy means they are the same thing, same compounds or elements, but their arrangements will be in different forms, so that they will have different physical properties but same chemical properties. Why they have same chemical properties? Because they contain the same thing, so chemical properties should be same. Okay, carbon exists in different allotrophic forms. One is the crystalline form. Write down crystalline form. Okay, in the crystalline form, Examples are diamond, graphite, okay, Buckminster, fullerenes. All these comes under this. Another one, okay, is the amorphous form. We'll just write that. Buckminster means that one scientist name who had found that. In this Buckminster fullerenes, that is carbon C60, it is there. That means it contains 60 carbon atoms together in the crystalline form. Second one, it is the amorphous form. Okay. Example, coal, charcoal, all this. Okay. These properties and all you will write. No, you know this. Anyway, I'll go for the next topic. So much is there still to do in this. Just write about its properties, I think. Huh? Structure, how it is there. Anyway, it's there in the book. Not much is there.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.